This is Computer Science 1213, Introduction to Computing. My name is Chris Rule, and this session is part 1 on typecasting. The worksheet says that primitive data types in Java have a predefined size which determines the range of values that can be stored in each type. Boolean, which is a logical, a true or a false, character 2 bytes, integer 4 bytes, and double 8 bytes. Now a bit is smaller than a byte. It takes 8 bits to make 1 byte. And a bit has a value of either 0 or 1. So as it shows here, if you have 2 bits, you can store 00, 01, 10, or 11. And if these are binary, this would be in decimal as 0, a 1, a 2, or a 3. That was 2 bits. Consider 3 bits. It says, what are the number of values that can be stored in 3 bits? Here's a table with 3 bits. The first bit has a 1 in it. This next bit, well, you could store a 1, 0, 0, a 0, 1, 0, a 1, 1, 0, a 0, 0, 1, a 1, 0, 1, a 0, 1, 1, or a 1, 1, 1. Now those were in order. And you add these values up as you go along. If you're using one of these values, then it's a 1. If you're not using one of these values, it would be a 0. So if we were going to figure out a 3 using these, then I want this first one to be a 1, going right to left. I wanted this next one to be a 1. These two and this one added together would give me 3. I don't want to use this last one here, so it's a 0. So a 3 is 0, 1, 1. These questions in part 1 are all related to using 3 bits. So you can answer those. Now, down here on this table, 1 byte is 8 bits. 2 bytes would be twice that, or 16 bits. 4 bytes would be 4 times 8, 32 bits, 32 bits. And then 8 bytes would be 8 times 8, which would be 64 bits. So 8, 16, 32, 64. Now what you can notice here is that each one of these bit numbers is the exponent for a base 2. So the number of values would be the number 2 to the 8th. And that would be equal to 256, if you calculated that out. That's 2 times 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 2. Gives you 256. That's the number of values. So if this is twice that, 2 times 8 which would be 16 bits. Then this would be 2 to the 16th. And that would be equal to a much larger number than 256. It's actually 65536. That's the number of values. Let's take a look back here for a minute. What is the smallest number as a decimal in base 10 if you use 3 bits? Let's look at 2 bits. 2 bits can store 4 values. The first value is 0. So that counts as one of the values. So we can't start counting with 1. We have to start counting with 0 because it's a valid value. So the largest number, if you have 256 values, is 255. That one that's different between the two is the 0. So you start counting with 0, then you go to 1. Well, that's 2 values, but the largest number is 1. So the largest number will always be 1 less than the number of values because of 0. So this next one, would have to be 65535. 1 less. So I'll let you figure out the values for 32 and 64. This would be 2 to the 32nd and 2 to the 64th. I'm guessing you'll need a calculator. Please use scientific notation in your answer. Number 3 says to look at an ASCII table, and when I scanned the document, the ASCII table did not come out, but you have one on your worksheet. Excuse me. And what you should look at, if you use the one on the worksheet, are the numbers that end with a lowercase d, which is the first column in each set of 4. For example, 0 is 048 D. You want to use the D number for your answer in A, B, C, and D on number 3. And it's just a matter of looking them up. It's not that difficult, but just make sure you use the right column. On these right here. The integer that's associated with each of these is the D number in the table, or the decimal number if you're using a different table. All right, number 4. There are actually 4 different data types for integers stored in 4 different sizes. A short is an integer stored in 2 bytes. 2 bytes has 16 bits. 16 bits has 65,536 possible values, and the largest number is 65,535. What range of numbers could be represented by a short data type? if you're using only 0 and positive. So give me a range, put the first number there, then a line, and then the second number. And you can pull those numbers from the table up above. We just looked at them. But in reality, negative numbers are also represented by integer data types. One way to represent negative numbers is to reserve 1 bit for indicating positive versus negative. What range of numbers do you think are represented by a short data type? So let's take a look up here. We said it was 2 bytes. We have this many values. This is the largest number, but these are all positive. How do you get the most negative and positive numbers so that you have the same number or close to the same number of positives and negatives? You only have this many to work with. So divide it by 2 might work. But then you also have to take into account 0, because 0 is not positive or negative. So they're just one of those. Maybe you should include the 0 with the positives. There's some hints in there. I'll let you try to work that out. What range of numbers do you think are represented by an integer data type? All right, let's go back up to the top of our paper. An integer takes up 4 bytes. Now 4 bytes, 8 times 4 is 32 bits. And 2 to the 32nd, whatever that number is the number of values. And the largest number will be 1 less than that. 2 to the 32nd. But then there will be positive and negative values so we're going to need to divide by 2 and account for the 0 on letter C. So let's look at our two bits item. Two bits would be 2 to the second. If we only had 2 bits, be 2 squared, which would be 4. And it'd be these 4 right here, 0, 1, 2, and 3. And what if we wanted negative values and positive values? Well, we would have 0 and we would have 1 we would have -1 and we would have -2. Because I'm including the 0 with the positives. So we have 2 positives and we have 2 negatives. And use that same idea when you have more than 4 numbers. So if I divide the number I have by 2, the answer is 2, because I have a total of 4 numbers here. But instead of having 0, 1, 2, 3, I'm going to have -2, -1, 0, and 1. I'm going to include the 0 and 1 as positives, even though 0 is not positive, and the -2, -1 is my negatives. So when you're looking at number 4, use that same idea. You're just going to have bigger numbers. Number 5 is related to number 4 because number 4 talks about the short data type and the integer data type. So the integer data type gives you a range of numbers, a big number that's negative to a big number that's positive. And the largest integer that you can have, based on using 4 bytes, with half of them being negative and half of them being positive, that's the number that goes here. The smallest integer value is going to be the negative end of that range. So the range of numbers on 4C is going to be the answer to A and B here. This A will be the positive number and B will be the negative number that you had in 4C. If 5C, when you write a Java expression adding 1 to the largest integer, you get an error. It may be an overflow error or an out of range error, something like that. But it doesn't know, the computer doesn't know what to do when you go past its limit. So it throws an error. Now this last one has to do with the ASCII values in decimal of the capital letter A and the capital letter Z. So you'll need to find the values of those two in the ASCII table on your worksheet. Add them together. That's what you get for A. And then show how that came about, how you got that answer in B. But you have to use the ASCII table and use the decimal values to do that. And that concludes part 1 of typecasting.